Let's look at some sentences. What do you notice among these sentences? The conclusions of these sentences are not certain. Let's examine the first sentence. Here, we cannot say that Rahul will get a first class in the annual examination. He may or may not get a first class. Thus, the prediction of getting a first class depends on his performance. Similarly, we cannot predict the happenings described in the other sentences. In such sentences, the words probably, doubt, and chance involve an uncertainty. These words are all synonyms used to indicate the term probability. Probability is defined as the likelihood of something occurring. Now, let's perform a couple of activities. In the first activity, we'll find the sum of the measures of the angles of some quadrilaterals. We know that the sum of the measures of the angles of a quadrilateral is 360 degrees. If we perform the same activity for any quadrilateral, the result will be the same. In the second activity, we'll measure the sides of some equilateral triangles. We know that the sides of an equilateral triangle are equal. Here also, we'll get the same result if we perform the activity any number of times. Such activities are called experiments. In the above cases, we can predict the results. However, there are some experiments where we cannot predict the results. Let's look at an experiment where a die is rolled 10 times. Every time we get a result. Can you predict the result if you roll the die once again? This cannot be predicted because we do not know what we will get. It can be any number from 1 to 6. Such experiments are called random experiments. Mathematically, a random experiment is an experiment that has more than one possible result, and it is not possible to predict the result in advance. The possible result of a random experiment is called its outcome. For example, the outcomes of rolling a die are 1, 2, 3, and so on. The outcomes of tossing a coin are heads and tails. A random experiment can have any number of predictable outcomes. The set of all the outcomes of a random experiment is called sample space. It is denoted by the capital letter S. The sample spaces of rolling a die and tossing a coin are represented as shown. An element of a sample space is called a sample point. In other words, every outcome of a random experiment is also called a sample point. Let's perform an experiment where two coins are tossed at once. Each coin can turn up either heads or tails. Therefore, the possible outcomes may be heads on both the coins, heads on the first coin, and tails on the second coin. Tails on the first coin, and heads on the second coin. And tails on both the coins. Therefore, the sample space of the experiment is as shown. The outcomes of this experiment are the ordered pairs of the outcome of the first coin and the outcome of the second coin. For the sake of convenience, we may omit the commas from the ordered pairs. In set builder form, this can also be written as S is equal to x comma y, such that x is the outcome of the first coin and y is the outcome of the second coin. A collection of the outcomes of a sample space is called an event. In other words, a subset of a sample space is called an event. In this example, some of the events are shown.